This next video I want to approach from a different perspective than a glass blower. And what I mean by that is I don't do scientific glass blowing because I want to. I do scientific glass blowing because I need to. That's how I learned it as a graduate student and have learned new techniques ever since then. So what I'm showing right now are my solvent stills. Now my solvent stills are basically still being set up because we moved into this brand new laboratory and then of course we got shut down for COVID in March. So now I'm bringing this up. So right now this is an empty round bottom flask, and then it goes up to the solvent head and so forth. You can see there's a nitrogen stream right there. I'm not going to go into the details of my solvent stills. Right now what I'm doing is leak checking them both for nitrogen gas, the inert gas, as well as the cooling water. With this particular design of round bottom flask, it has the advantage of a little Teflon plug that I can remove so I can add solvent. Well, that's all fine and good, but here's the problem. So let's say I just grab a funnel and take that and place it right here. Well, you can see this angle is gonna be a problem. Even if I go with a funnel that has a more narrow stem that I'll be able to insert deeper into the still. If I try and pour solvent into the funnel with the funnel bent, or I should say with the funnel at an angle of about 45 degrees, well, what's going to happen? I'm going to spill the solvent everywhere. And trust me, I know this because I tried to do this. I cut the stem to a much shorter funnel and tried my best to very carefully pour the solvent in, and it wasn't going to work. So what I needed was a funnel that had a stem that was curved. So that's what I'm going to show next, and I'm going to use one of these field tubes to do that. And in this case, what I'm really just doing is bending the tubing and then cutting it and fire polishing it. But the reason why we do it is more important. And so this was the first one I made. So I took a standard long stem funnel like this and I cut it to length and gave it a slight bend. I actually had to make some adjustments to the end of it because the first time I did it, the output was way too small. It worked, but it was way too small. You can see that's going to be much better for pouring solvent in here. Now, normally what I would do is instead of just putting it in there with glass on glass, here I've got the field tube version of it, and I have a rubber Subaseal that's actually backwards, but it gives it a better fit. So that way it will hold it into place. This particular field tube, I bent it a little bit too much. And so I want to make another where this bend is just a little less sharp. And you can see what I'm going for here of trying to have my funnel at approximately 90 degrees or 180 depending on your perspective, so that way when I pour the solvent in. But here, now I can finagle a little bit and push it in a little further and so forth, but I'd be better off just making another one. Now the reason I'm using these field tubes is we actually have a whole bunch of these that probably are older than I am, and that's not an exaggeration, that have been sitting in a box forever. So this is a perfect application for them. And again, the idea is to go from a long neck, a long tube or neck, field tube funnel to something that is much shorter and has a curve. So this bend is, again, a little bit too aggressive for what I want, but it would still be functional. So this is a case where I'm doing glass blowing for a very specific function in my laboratory. So I'm not doing it simply because I enjoy working with the flame or anything like that. I need to pour solvent into my solvent stills, and I need to do it in a way where I'm not going to spill it everywhere. And the best way to do that, again, is with a funnel, but that funnel has to have a stem with the right length and curvature. I want to say this funnel I made 2 days ago. This one I made about 2 years ago, and a couple days ago I opened up the output here because this was literally like a pinhole. I didn't remove the end properly, so I came back and opened that up quite a bit just this week. Okay, so I've got a field tube. I've marked off about 1 inch of where I want to make the bend. So I'm going to rotate in the flame, heat back and forth. It's so thin I probably don't have to rotate that much, but I will. And then I'll blow here. I could hook up a blow hose, but for this it would be kind of awkward. And I've got a wooden cork here to give me some back pressure. So, yeah, with this, rotating it is awkward. So I'm going to just go like this, back and forth. Or, you know, I can feel it starting to soften, so. So we'll see how that does. Now, again, my technique was anything but perfect. The key is I have a soft curve, which is what I was going for. I don't need it to be at, obviously, you know, and I'll put this in the still to see how I did, but I want a reasonably long neck here, so I have some space to pour in the solvent. I'm going to cut it down here once it cools. I don't want a constriction at the bend, so as I was bending, I was also blowing in on this end to help that from collapsing. But without a doubt, the biggest mistake that I very often make, I don't want to use the past tense, in making a bend in tubing like this, is I heat up too small of an area, and then when I bend it, I end up bending at a right angle. So I tried to make sure that I was heating up about an inch of the glass, getting it nice and soft. Because of this weird field tube end here, instead of doing like a standard rotation where everything is, I just kind of wobbled it back and forth and just kind of went back and forth to try and get this area heated uniformly. So comparing these two, can't quite line them up. They look pretty similar. I was hoping I might have put too much of a bend in here, but we'll see. Okay, so I'm going to cut this to length. There are several ways you can do it. Normally I would just grab a triangle file. See if I've got one of those lying around somewhere. But I've actually got some very nice glass cutters. So take this. My measurement doesn't have to be exact. Squeeze and just go around. You can see there's a white line forming in the glass. Let me pause and I'll take a photo of this to highlight it. So now I've got that scratch mark. It doesn't go all the way around and it doesn't have to. For good luck, I licked my finger. I put just a teeny tiny bit of saliva on it, and you can see there this was so well scored and such, it just literally broke without me putting in any effort. Normally what you're supposed to do is you put your thumb back here and then you give it a little pop. Literally I just touched it and it broke. So for good luck, I licked my finger. I put just a teeny tiny bit of having something, this little Jaws guy, that gives you an excellent score, so there's a cutting wheel here, can definitely make your life much easier. I'll have a video on scoring and snapping cutting glass, tubing, and rod later. What I'm showing here is a iron or steel triangle file. This one is very, very old and rusty. I actually found a box of these when I first got here at Radford that I'm actually soaking these in WD-40 right now to try and remove some of the rust. But this is how I learned how to cut glass tubing, of taking a triangle file, usually a rusty one, and scoring the glass and snapping it. Whereas this cutting tool, there are different variations of them, or something as really awesome as this tungsten blade. Actually I've got it right here, I might as well show it. The other way to do it is with a glass cutter like this. I've had this glass cutter now for gosh, about 30 years. I can't remember if I got it when I was at Texas Tech or at UCLA. You can see I scratched my initial into it because I was worried about everybody stealing my stuff, which is very common in chemistry labs. But yeah, I've had this little guy forever, and it works fine. It's just that now, again, there are much, much nicer ways to cut glass. But yeah, so first I learned with the triangle file, and then I upgraded to this little glass cutter, and I'll have a video on the different techniques for cutting glass. Now, as far as the funnel, well, the edge of the glass that I just cut is razor sharp, so I'm going to need to fire polish this before I can test it in the stills. Something I just realized when I was doing the scoring and snapping is I forgot to put on the Dinium filter on my camera. So The two examples of bending the glass tubing are going to have that sodium flare. So I'll look at this, and if that video is really bad, I'll refilm it at some point. Now I'm going to go ahead and fire polish the end of this. Now, if I was a real glass blower, I would actually clean this edge up. I would have used a different technique rather than scoring and snapping it. But I'm a chemist, and I don't care if the edge basically looks like somebody took a jackhammer to it. That's not my concern. My concern is that it works. And what I've got here is a tungsten electrode that's used in welding. And I'm just going to go in there and make sure that the edge doesn't collapse on itself. So I don't want to flare this. This glass tubing has a narrow enough diameter that even if I did flare it just a teeny bit, it wouldn't be an issue. But I want to basically make sure that the edges, and this is way overkill, that there are no sharp edges, and that I've got good flow of the liquid that's going to go through here. Now, what I meant by if I was a real glass blower to clean this up, when you score and snap the glass, it damages the edges of the glass. Basically, you have lots of cracks and probably air occlusions that are trapped in the cracks and all kinds of mess. And when I fire polish it, well, all that junk gets trapped in there. If I was going to take this and seal it to something else, my seal would be inherently defective because of all the cracks and air bubbles and other junk that might be stuck in there. But this is just the end of a filter, of a funnel, so it doesn't matter from a chemistry point of view. So that's why I'm being lazy. So right now, I'm going to let it cool down, and then I'll size it up to see how it works. I might make some adjustments to this or the first one, but again, this video is about function, not as much about the glass blowing technique itself. And oh yeah, what I was going to mention is I will probably anneal this glass at some point, but this is thin enough glass, and the way I've worked it, that it has stress in it, but not a tremendous amount, nothing that's going to make any difference. But it is always a good idea to run your glassware through a full annealing cycle to remove that stress. However, for the funnels that I've showed you, I have not done that simply because it's not necessary for the function of the funnel. That's not my concern. My concern is that it works. And what I've got here is a tungsten electrode that's used in welding. And I'm just going to go in there and make sure that the edge doesn't collapse on itself. So I don't want to flare this. Okay, so let's see how we did. Again, this Teflon plug comes right off the side. I've already put a Suba-Seal on here. Push that down. So there's my bend, and the fact that I'm not gushing blood through my fingers means my fire polishing was successful. So we can place this here. Actually, let me do this. So again, the red Suba-Seal is to give me an airtight seal. And I've got some play that I can slide this in here, and so that's pretty good. So you can see that now my funnel, which I would add solvent to my stills, the reason I like the Thiel tube more than a traditional funnel is it's more compact. So again, this is what I have been using. I modified it to open up the end because it was constricted. But now I'm essentially going to go and use these Thiel tubes because they've got a much narrower profile, and they'll do the job, which is basically to let me take a beaker of solvent and carefully pour it in here while under nitrogen. And again, if I was using a straight funnel, or a funnel with a straight stem, it doesn't work. You end up spilling solvent off to the side, so it becomes very, very awkward. So again, the purpose of this exercise, again, was to show that there's a reason why a chemist needs to have scientific glassblowing skills.